Hello everyone. So in this video we will be discussing the lab called decomposition of malachite. So as always, you are going to enter your Blackboard site, your lab Blackboard site, the 1105, not the 1305, and you'll see the main landing page which contains your laboratory material. You're going to head over to the decomp of malachite lab. As always, you're going to open up every corresponding page because it's important, of course, and each link leads you to first the background, then the procedure, which contains the actual link to the lab simulation, and then the lab assignment. And as always, remember that there are extra videos usually that I'll include that will provide some sort of insight or more practice or just more information on how to work through the lab. So once you open that up, here is the background, for example, and once you read through this, you'll see that we are starting to convert to moles in this lab. And we are working with stoichiometry in this lab because you are at the point in lecture where you have encountered stoichiometry as well. So malachite, what is that? So malachite is a type of stone, but it's a little bit special where whenever you heat it up to a certain temperature, 200 degrees Celsius, that's very hot, it decomposes into copper oxide and other products. So you start off with this Cu2CO3, and then you end up with copper oxide and a few other products. And we'll see the balanced chemical equation in just a little bit, but keep this in mind. You're starting with this compound, it's decomposing into a smaller compound, CuO, a less complex compound, and other whatever's left over. So chemical reactions, they follow the law of conservation of mass. They do not just go into nothingness, whatever you're reacting. Remember that whatever you start with, you always have to end up with somehow. It may look a little bit different, but you're going to end up with the same amount of atoms on both sides. So for example, here you have solid magnesium reacting with hydrochloric acid. And the way that this reacts is you have certain ratios. So you have 1 magnesium mole to 2 moles of hydrochloric acid. It's the same way how in a recipe, a cake, recipe may call for, and I'm just completely making this up, don't take this seriously. I'm not a baker, not a professional baker. So let's say a recipe calls for 2 cups of flour, 1 cup of water. 1 to 2, right? 1 cup of water to 2 cups of flour. So that's the same thing here, except it has to do with atoms or moles, whichever amount that you happen to be looking at. But that's what these ratios mean, that they are following a certain recipe. That's all it really means. So your coefficients always tell you that ratio, and how you actually calculate those moles and how you can go from moles of one thing to moles of another is by taking, for example, here, if we calculated moles of hydrochloric acid and we multiplied it by the ratio, which is 1/2, we would end up with moles of magnesium chloride. So these ratios are really useful because they can take us from one thing and by thing I just mean one component within this chemical reaction to another component in this chemical reaction. So it's very powerful. And here is just a review on how to calculate moles. So moles, you always, N signifies moles here. N right there, number of moles. M is the mass, like the actual mass that you measure on a balance. And then big M is molar mass. So here are the 2 different ways you can get to either of these either of these values. So for moles, you take the mass divided by molar mass. If you were to set up the dimensional analysis, you would see, I can't talk today. Dimensional analysis, you would see that situation. And then if you want to get to mass using moles and molar mass, you multiply them by each other. And you'll see that once I do I'm going to demonstrate some dimensional analysis related to this lab for you at the very end. So what are we doing in this lab? So remember way up here at the top, we mentioned that malachite happens to decompose into copper oxide. So that was very important, because that's what you're going to be doing here. You're going to be heating a known mass of malachite. It's going to produce copper oxide, and then you're going to compare the amounts. You're going to see, okay, I had this amount of malachite. To what ratio did I get copper oxide? What was the ratio, right? So you're going to observe this experimentally. You are going to make some qualitative observations, meaning you are going to see some color changes. Visual changes, and you will also do some quantitative observations, meaning you're going to record some numbers, you're going to record some data points. And for us, these are masses. So once you go to the procedures, you'll see that, starts off slow. Take a crucible, take a balance, get all your instruments ready. And then the important things that I highlighted, which I always like to focus on that. Move the crucible onto the Bunsen burner. So you'll be getting a crucible. So here I opened up the lab. As always, you know that you are going to click up here to enter this lab. You're going to put on your PPE. You're going to enter the lab. And then you're here, right? So what I did so far is bring over my crucible and bring over my Bunsen burner, because I know that those two things are going to be very important. So what are the things that I want to point out to you? You are going to be using the cutaway view, so keep that in mind. And to get there, I'm going to remind you how to do that. And then the other thing I wanted to point out, which I forgot to highlight, is to turn on the Bunsen burner to a medium flame. And then finally, you're going to watch the crucible until the malachite decomposes. You will see a distinct color change, and I'll let you witness that color change. I'm not going to tell you what color, but you'll see a color change. Now, what's important about this, to get to medium on the Bunsen burner, you click on it twice. So you will be using this light blue flame, okay? That's how it should look. To bring the crucible onto here, you just put it right there on the flame, and it'll automatically generate this little crucible and ring stand. And to do the cutaway view, you click on the crucible twice. So I double clicked it and then show material, done. And I would highly, highly recommend you to zoom in, because that way you can see the color change that happens within here. And that's the main idea of this lab. You're heating up malachite. Now, remember, there are a lot of mass measurements you're taking, right? Take a remember, you're going to need the balance. You are going to record the mass. It's in several places where you record the mass, okay? So don't forget that. I know I didn't really demonstrate that, but that's because I completely trust that you already know how to do that, and you don't need me to show that or remind you of that. But you're going to be recording the mass several times, so definitely make sure to keep your whatever it is that you use to take notes or to record your findings. Keep that right there next to you, because you are going to be recording masses. And that's about it regarding showing you how to set up the lab and just things to watch out for. Remember, you're watching out for that color change. But other than that, just make sure to record things to the correct amount of sig figs, to keep that handy. Don't, misplace those measurements, those mass measurements, because you will need that for the questions in your lab assignment. So now that we're past the background and the actual procedure, you can open up, right, or whenever you wish to, you can start your lab assignment. Remember, I mentioned there are qualitative findings that you're observing in this lab. By qualitative, that usually means visual, things that don't really have numbers attached to them. It's more characteristics that you can, like I said, see visually. So, what color was the malachite before heating? So, that's something simple that you observed. So, I am finding more and more that I recommend to skim through these questions before going in for your experiment and for recording all the data, because that way you'll kind of have an idea of, okay, let me record the color before, let me make sure, because I'm gonna have to answer question number 1 about that. So it kind of helps guide you a little bit more and really shows you the importance of keeping those good notes as you do the experiment. Anyway, as always, you have some multiple choice questions throughout this assignment. And then you will also have some open-ended questions at the end, of course, as always. Notice here that there are some calculations you have to complete. I am going to demonstrate how you do this, so don't worry. Just model anything that is regarding calculating moles. Just model it how I show you in just a second. Okay? So don't worry about these questions. They look hard if you haven't practiced, or if you just you need some guidance. Don't worry, we're gonna go through it together. So yeah, these are more qualitative, just knowledge about the types of reactions in general. And then we get to these questions 17, 18, and 19, and these are a little bit challenging because they require you to do some calculations related to what we are recording and completing in the lab. So what I did was I transferred these questions over to a Word doc. So we're going to discuss this. So here I have the balanced chemical equation for malachite decomposing. So let's kind of label this just so we have an idea of what's going on. I have malachite right here, and then I have my copper oxide right here, this solid. These other two components are some easier, more common compounds that you already know about: carbon dioxide and water. These are actually in the gaseous state. So whenever malachite starts breaking down because you're heating it up, they actually are released as gas. So whatever solid you have left in your crucible is completely copper oxide. Now, I'm kind of giving it away because I'm showing you the balanced chemical reaction, right? And this is actually one of the questions in your lab assignment, but it's okay. The point of me showing this to you is so I can demonstrate how we use it to confirm our findings that we're about to go ahead and calculate. So number 17, it asks you, what is the ratio, the stoichiometric ratio, between the number of moles of copper 2 oxide produced in the reaction and malachite? The molar mass of malachite is blah blah, and the molar mass of copper oxide is blah blah, 79.55. To calculate the mass of malachite, use the data you recorded using the balance. So that's where your data comes in, right? You're literally using what you recorded, and you're calculating moles and seeing what the ratio is. So how are we going to do this? What we are going to do is calculate moles that we started with of malachite, and then we are going to calculate the moles of copper oxide that we ended up with. We are going to see what the ratio is between those two, meaning we're dividing, and then we are that's our stoichiometric ratio. So that's what it's asking for at the very end, right? Or that's the ultimate question here. So there's going to be two major steps here, or I would say three actually. First, we are calculating moles of malachite, and then calculating moles of copper oxide, and then finding the ratio by dividing the two. So to do this, I'm obviously not gonna ruin and spoil the answers for you. So instead, what I'm gonna do is just use some different amounts that you will not get. So you're gonna get something different. So what I'm gonna do is I'm gonna say that we started with 5.74 grams of malachite. Right? They gave us the molar mass of malachite, and that's what we need to set up to get to moles. So the way you set that up is you want the grams to cancel out. So what I'm going to do is put the number attached to that, to those grams at the bottom. 114 grams malachite. And then at the top is 1 mole malachite. This should give me my amount, right? So that will give you moles. And I'll calculate the actual values in just a second. And then let's say that we got, from our final results, we got 1 point. Okay, so I paused recording and I thought about what I'm showing you here. And I decided it's better if I just leave it as is without the actual number. And then you just model this to your numbers, because what you're going to get is accurate. These are just numbers simply for demonstration purposes, okay? So, don't take this and, be like, oh, this doesn't match mine. It's okay. We can pretend. We're just pretending for demonstration purposes, okay? So I'm just making up numbers. They're not going to be accurate, okay? But anyway, so you get moles of malachite over there. That's fine. You're done with step 1. Step 2, calculate moles of Cu oxide. So for Cu oxide, I'm going to say it's 1.98 grams CuO. And the amount of sig figs that you're recording to is actually more. So for example, whenever you weigh out your malachite at the very beginning, your balance actually has this many sig figs. So pay attention, pay attention to your scale, because what I'm doing here, again, hypothetical purposes, so it's a little bit different. I only have 3. And then we're going to set up almost the exact same way, except with the molar mass of copper oxide instead. 79.55 grams, 1 mole CuO. That gives us mole of copper oxide. What you will do next, take whichever one of these happens to be larger and divide those out. So most likely you are going to be getting moles of CuO that is bigger. Hint, hint. You're going to divide that by the moles of malachite. I'll just put mal. This should give you a small whole number. So this should give you like 1, 2, 3. What that means is that number corresponds to the copper oxide. So whatever number you get will be it should match, and I'm giving it away here again, but it should match the coefficients, hint, hint. So and that one for moles of malachite. So I know I'm giving it away a little bit, but that's how you get the ratio. So on the questions, let me go back there. This asks you, for number 17, what is the ratio between moles of copper oxide and malachite? So it tells you actually, moles of copper oxide is 1. Oh, I read this completely wrong. It's asking you for malachite to copper oxide. So we know that malachite is 1. So what you're typing in here is whatever number that you got here. So that works out perfect because whatever number you get here when you divide out, that's what you're typing into the question. So that's how you complete this question. So our next question is about predicting the mass expected from decomp of the malachite based on the balance equation and the mass of the malachite used in this experiment. The molar mass is, again, 221 for malachite, molar mass of CuO 79. So what are we doing here? What you are doing is calculating theoretical yield, essentially. So based off of the balanced chemical equation and based off of how much malachite you started off with, how much copper oxide should I technically get in a perfect world where I didn't spill anything, where nothing got stuck to the side of the beaker, where nothing got stuck to your scupula, I can't say that. In a perfect world, how much would you get, right? So what that is you will start off with the mass. I'm going to kind of give a flow chart here. Mass of malachite, and then we will go to moles of malachite. For moles of malachite, we will go to moles of copper oxide, and then from that, we will go to mass of copper oxide. Now, to do this, you will use several different conversion factors. Here it is the molar mass. Here this is the stoichiometric ratio, SR, stoichiometric ratio. And then here this is the molar mass, but of copper oxide instead of malachite. So let's go ahead and set that up. So let's again go back to this theoretical demonstration world of where we started this experiment with 5.74 grams malachite. Okay. And what I can do is actually copy this over. Lucky me that I have technology, right? Oh, anyway, I can move it over for my purposes. It moves some of it over. Anyway, 221 grams. Okay, here we go. So this is this first step right here. We converted to moles of malachite. We crossed out grams of malachite. Yay, good. What am I doing next? So here, the next step that we planned out was to use the stoichiometric ratio. And guess what? You just found the ratio. So whatever you found will actually go right here. So remember the problem on number 17 gave us that we have 1 mole of malachite. And then whatever number you got here will go here for moles, right there for a square. That's where you input it. Moles of copper oxide. And then you're done with that step. Malachite, moles of malachite cancels out. Now you have moles of copper oxide. Next up, and last final step, you're going to use the molar mass of copper oxide. You are going to convert it. Oops, and I was about to set it up wrong. Hope you caught me on that before I did. That means you really got this down. So this time it's mole at the bottom instead, because we want to end up with grams. Grams, CuO. And then that gives you your theoretical mass. So that's how you would set this up. So once again, these are demonstration purposes. That's why I have this different number right here. Yours is going to be different. And then this square right here where we have the mole of copper oxide, you will fill that in with what you got for number 17. And then finally, this kind of continues on. These are problems that kind of build on each other. But number 19 actually asks you to calculate the percent error of the experimental mass versus the theoretical mass. So what we just calculated, what you get here for this previous problem on the answer is your theoretical mass. So you are going to fill that in right there, theoretical, as well as there. So your number from number 18, your answer from number 18, your answer from number 18 will go there. So yay, you got two things out of the way there. Now, what about the experimental value? Well, you actually calculated that up here. I was like making sure. So you actually calculated that right here. So whatever moles of copper oxide that you calculated on number 17, that's what's going to go here. So the moles of copper oxide on number 17 goes there. So you have everything already. It's just a matter of plugging in. And this will tell you how much error there was. In other words, how much you lost of this copper oxide that that obviously did not match the perfect world, the theoretical amount. Okay. So that's about what I wanted to go through for this lab. I don't want to go on too longer. But I think with this guidance that I just showed you, these demonstrations, I think you will be good for this lab. And of course, as always, let me know if you have any questions at all and we can figure that out. And thank you for watching this video.